Okay. Thanks a lot for having me, Max. I'm very glad. Very unexpected, but it's really nice to see you all and meet some of you. I knew through your research a little bit. I'm really sorry I missed your presentation this morning. I had a staff meeting, but I really wanted to hear more your thoughts on hypothesis testing. I'm going to tell you about a project on forecasting research results. And it's a good example of what I'm trying to do a little bit, which is to try to bring two fields that I really fond of, which is on the one hand, behavioral science and decision science, and on the other hand, meta science. And I'm trying to think about ways of making them communicate with each other. I think that's one way we can push the research frontier. And for that, I'm trying to work at the moment on developing an incubator for experimentation in science, trying to really think about doing this in a systematic way. It's called Lab Square for Lab of Labs. What we are trying to do is build a consortium of labs in Europe and hopefully across the world, where we're going to be able to keep track of data that is being collected there in a really just natural ecosystem, but also enable experimentation at a large scale on research practices, thinking about, for instance, measuring the causal impact of things like pre-analysis plans on information disclosure, the various aspects of research, trying to enable systematic replications and trying to really think about how to do this in high-powered ways, trying to think about stability of results and how our many degrees of freedom can influence the way we assess evidence. And there is a second part to this, which is trying to really understand in a very natural environments, projects and their life from A to Z. So very often we know a little bit of the story behind the project, but not very much. Sometimes that starts with a pre-registration, but often we're only left with a working paper on just publication. So what we want to do is try to combine metadata with longitudinal surveys of researchers, trying to measure their preferences and beliefs. We could see already from Karen's talk yesterday that it could be actually very informative. And more generally, trying to think about bringing crowd science to economics, trying to make science a bit less black box and also crowd science a bit less black box. I think there are a lot of studies where we observe the distribution of results and it's not completely clear how to interpret what's the decision-making process that researchers went through. And so we're trying to do this. I've been saying we because
what do you mean by crowd science?
Crowd science, thinking about crowds of researchers working all together systematically. So very different organizational research. Yesterday we spoke a lot about sort of fixed costs and how we absorb them and trying to think about doing things at a large scale. That's what I'm about. So I've been working on this with researchers who, some of them have been working mostly in meta science, thinking about Anna Drever, Magnus, Johannesson, and Levent. And then I've brought with me Aurélien, who really works in more decision science, and Taisuke works at the intersection of the two. So we're trying to work together to really think about the psychology of scientists, of experimentation, how can this help us understand the way they shape, access, evaluate evidence, and trying to think about doing this experimentation at a large scale. We have also been working with a lot of junior researchers. Actually, Adam is here in the room, trying to really think about file drawers and the life of projects from A to Z. And today I'm going to tell you about a project with Daniel, who also has been working with me now for quite a few years. And since I really care about telling the story of projects, I thought I would tell you the story of this project. In fact, I also have a podcast that I started about 3 or 4 years ago with students from Oxford.
Can you maybe minimize the video?
Oh, this?
Yes, please. Minimize.
This? Okay.
Here on the 3 dots, actually controls. Down.
Down. Up. Hydraulic within controls. All right. So a podcast to kind of think about the story behind projects, thinking about theory papers. I think it's so interesting to kind of think about the choice of paradigm that people are working with, change of assumptions, how they might evolve, And same thing for the way we design evidence and arrive at research questions. So that's my attempt to do this in the seminar. I started to work with Daniel because we worked on a report on peer review. Actually, Adam was also working on it. And Daniel worked so hard, brought us and taught us so much that actually we decided that we should become a co-author. And that is okay. Pitch this idea of this, trying to understand the project I'm going to tell you about, which is about predicting research results. In fall 2022, trying to think about, again, developing this consortium of labs and trying to think about crowd science, we felt like forecasting was really an example of that, leveraging the wisdom of scientific experts to try to understand a little bit how to evaluate evidence. And Daniel, as it turns out, at the time was still a master's student and was working on forecasting and prediction markets from a very different angle, looking at it more at political events. So yeah, we asked Daniel to read a lot of papers. He is far more expert than me presenting this slide, and I feel almost ashamed that he should be here presenting. And then we gave a series of discussions, presentations. So Toussaert started to do this in May, and we've been doing this. And the point is, our overview document is growing in ways that we didn't necessarily expect. And that's something that I'd like to hear from you guys, how you would want to see this discussion going. So yeah, it was very unexpected. I was supposed not to present. On Sunday, we said that maybe that could be something we need to do. And so what I'm going to present here is going to be quite preliminary. Between our review and research frontier. So what I'd love to hear from you is, I see this project as a big octopus that has been growing many arms, and I'm wondering how many arms I should grow and how many arms we should kill. So I'd love to hear this. Yeah. Okay, so let me tell you about where the project is. So beliefs are very important for research results. We spend tons of money, as we've been discussing. Marco yesterday spoke a lot about grant making. We spend a lot of dollars on research, and for this we have to evaluate the merits of proposals. Researchers themselves, they use their own beliefs to choose projects, to give advice to their students about whether something is going to work or not, to evaluate, right, in the context of peer review, manuscripts. And often those beliefs, they are implicit, but more and more now there's this effort to make them, elicit them directly. So they make them more explicit as part of the process. And despite the stakes that come to the use of these beliefs, the overall accuracy and the informativeness of forecasts remains quite unknown. I mean, I'm going to be talking about contexts where we're going to try to, for instance, forecast effect sizes. Might be useful to try to really understand whether accurate. And on top of this, the returns to eliciting forecasts directly are not always very clear. So I'm going to discuss why people might want to collect forecasts, how to evaluate this, and what people do in practice.
So I guess Eva Weaver, that's Stefano Della Vigna, had this forecasting project. How do you think about this in relation to that?
I'm gonna show you this for you. So the first thing we're trying to do is trying to really just understand the origins of this practice of forecasting. And as you mentioned, Della Vigna and Eva Vivaut have been kind of trying to push towards systematization of this practice. But it's actually quite old, so I'll give you an example of this. Then what we want to do is we want to look at current practices, really trying to think about this as a stock-taking exercise, and trying to evaluate forecast performance. And we want to discuss possible paths forward for not only improving the forecasting accuracy, but also trying to think about potential use of this practice more broadly for improving science. Okay, so let me give you an example of what we're going to be looking at. So there's this cool paper that was published in Science. In fact, we did a podcast episode on this paper on the behind the scenes of this project. And it's about trying to think about honesty around the world, looking at this lost wallet framework. So researchers went to different countries and asked research assistants to randomly drop wallets and see who would return the wallet. And what they try to do is try to understand how this would depend on the content of the wallet. Okay? What's the return rate? So they did this large experiment. And here were the various dimensions that they varied. Some treatments, the wallet had no money. In one treatment, there was some relatively small amount of money and was harmonized across countries. And then in one treatment, the amount of money was very large.
So, was there other things like driver's licenses in the wallet, so even if it has no money, you would be valuable, if not to you, to the person you're trying to?
I forgot what they put in it. I think they put a little bit more than just the money, but I wouldn't be able to put it.
So I'm just wondering if it's like, yeah.
In the context of no money.
If I found a totally empty wallet, I wouldn't try to return it because I just think whatever, if this person is missing it.
Yeah. I think there was something else, but I wouldn't be able to. They might have varied other things like you mentioned. So what they wanted to see is they went to economists and they asked, how should you order these treatments? I mean, what do you think was roughly the ordering or even the levels? I mean, there's a question about levels and there is a question about ordering.
It's returning the money or returning the wallet, or they could return the driver's license and keep the money.
Returning the wallet in.
The one with $13.
The one with $13 more often. Ooh, okay. What's your intuition for this?
I don't know, like if there are $94, maybe you want to keep them. There is no money, you think, well, it's not gonna be useful.
Right. Okay, the temptation is this.
Yeah.
Okay. So what we observe here is that about people predict a little bit above 2/3 return rate, regardless of the treatment. It could reflect that people are quite interested in terms of the ordering this. And of course, a Homo economicus would dictate a monotone relationship here on downwards. And what's the actual return rate? Well, the monetary relationship is upwards. So people actually are more likely to return the wallet if there is more money. And the explanation they do with this additional series of treatment is this notion of theft aversion. So people feel really guilty if they don't return money. So here, right, the forecasts provide contextualization for the results. Maybe after the fact, it looks really obvious that, oh yeah, of course, we're social animals, we have social preferences, but it says the Homo economicus would have said something very different, and in fact, economists are very specific. So what we want to try to understand is who participates in this market for collecting forecasts. We want to think about the demand side, so researchers collecting forecasts, the commissioners, if you want, and then the supply side, the forecasters themselves. The second thing we want to do is we want to try to understand this why researchers collect forecasts. Here I suggested that understanding results providing context would be important, but there could be many reasons for using forecasts. Then I'm going to talk briefly about how forecasts are elicited. Of course, here there are many ways of aggregating information and asking people to form their beliefs, and this could affect very much forecasting performance, for instance. And then I'm going to say a few things about accuracy. I'm trying to think about performance and informativeness of this forecast. So, very short overview. Unfortunately, I cannot do justice and replace economic historians, but I'm going to give you a very short overview of what we've discovered in the literature. And in fact, the earliest example of listing forecasts to evaluate research results comes from the Milgram experiments. If you look at the 60s, 70s, these very famous experiments on submission to authority, Milgram wanted to understand what other research would have expected, and when you think about predictions as providing, in these words, a benchmark for understanding how much we learn from an experiment. So, of course, at this time, there was no notion of open science or access to any of our data. So we're going to focus on much more recent literature. Here, I want to show you a little bit the distribution of papers on that contain forecasts over time. And here we stopped in our data collection in August 2023, but you can see that there is a growth trend. And the very first papers that we can see, or among the first papers, looked at replication outcomes. So you have studies, and I'll give you examples of how this is done, that try to assess the replicability of results for upcoming replications using prediction markets. And then almost about the same time, you had RCTs in developing countries being conducted, and also some researchers collecting forecasts in this context. And then you had now more of a movement towards centralization of the collection of forecasts. That's pushed by Stefano Della Vigna and Eva Vivard and co-authors using this social science prediction platform. So here the idea is to put together a panel of forecasters trying to evaluate their performance and trying to evaluate in a more systematic way studies that are being currently produced. So let me give you examples of what you can find in terms of practices. So prediction markets for applications work in a different way. You will have a set of papers that will be selected for a potential application. And sometimes they are used not only to evaluate the replicability of a study, but also to help select which studies are going to be replicated, so notion of decision market. And here's how this is typically formulated. There's this question that researchers, forecasters are asked to assess, will the replication results produce an effect that will be in the same direction as the original effect with a p-value of less than 0.05? Yes or no? And people are basically asked to trade on this conjecture. So they trade contracts that will pay $1 if the study is replicated according to this definition, and 0 otherwise. And then you have prices that are set at 50 cents, thinking about an informed buyer. And then participants are typically given an endowment. People are allowed to do short selling or long selling. And then you're going to have a market maker that will bring together all this information, produce prices via the logarithmic scoring rule. And then you can think of the price under the assumption of risk neutrality as the probability that the outcome is going to happen.
So for what is this criterion? This is for the social science prediction platform, or?
This is for prediction markets for applications. So here I'm giving you the example of what Anna Drever and her team have been doing when they conduct applications. They conduct typically prediction markets, and they ask researchers to train on these things ahead of the replication.
Well, it's part of why I'm asking is like I think it's kind of a pretty bad criterion for a notion of what it means to replicate, but
it's a definition. We can, of course, there are different ways of defining things. I'm not going to try to define the criterion, and I can see where this comes from. That's one thing that people concrete that people can trade on. How does this look like? So here, for instance, this replication market that they conducted selected AER and QJE papers from a certain period, and then people could trade on the replicability of the main results in this paper. So you can see the average price, and then the number of shares traded, and so on. That's an example of one such papers in the study. So here people were asked to bet on a specific hypothesis on one of those papers, and then you can see the fluctuation of the price. Here the average price, and typically as a measure of belief, they will use the closing price.
do you know the sample size for the replication?
The sample size of each replication?
Like when you trade on this market, do you know what sample size the replication study will have?
I think you told all of this information. Yeah, issues of power or this are important. So social science prediction platform. Let me give you an example of this. So that's the platform of Stefano and Eva. What you can do is you can go on the platform and you can see all the studies that are currently posted for collecting forecasts. And you will observe some characteristics of those studies. So for instance, here is an example of one such study. You will see the title, then the list of co-authors. You will know of the field and potentially people will disclose information about the goals of the reasons for collecting this forecast, whether they have collected data already or not, conditional on their decision of collecting forecasts, and how they want to use this for general. And then you can see these various studies available for providing forecasts, and then you can decide which one you want to use, you want to contribute to. Here is an example of how this paper formulated the forecast. So they looked at, they wanted to estimate the difference in the share of people that would get vaccinated between a treatment and a control group. And here, people were given as a benchmark the rates of vaccination in the control group, and then they were asked to think about the impact of the following treatment. Was a social benefits treatment that emphasized that getting vaccinated would also protect others. Okay, and then people were asked to think about this in terms of treatment difference using this slider. So design choices can be quite important to kind of think about eliciting treatment effects. Okay, so now I want to tell you a little bit about the data that we have to try to kind of think about understanding this practice. So in terms of the papers that we included in our review, we looked at primarily social science papers. We didn't find that many papers outside of social science. You could think of biology, for instance. We looked at it, we didn't find that many. We looked at papers that are fairly recent. So the most recent version should be published or publicly shared in 2015 or later. Then another inclusion criterion was that the paper presented at least one prediction of one target effect in a given study. And target outcome, not necessarily treatment effect. And then the forecast elicitation should not be part of the study itself. So it's we didn't want that the forecast elicitation itself affects the outcome in the study, but you can think of this more as an add-on to help or interpret results, for instance, or select studies. And then we, as a final criterion, thought about collection of forecasts that are elicited through the cooperation with the cooperation of authors or from the authors themselves of the target study. So we identified through this procedure over 100 papers, 104. 57 of them are currently published, remaining working papers. And for each of these papers, we hand-coded various features about the target outcome, the forecasters, and so on. And we have over 2,000 target outcomes in this data sets and over 40,000 individual forecasters that we can think about evaluating. So what do we code in those papers? We code the type of target study that people had to guess and try to think about the context in the study and the type of outcome. Also, there's a wide range of outcomes. Already I mentioned the replication outcomes, target effect sizes. Trying to look at this. And then we look at when and how people actually elicit this forecast. We code features of participants, thinking about the target population, but also the features of forecasters themselves. And then we look at the reasons that authors mention for collecting predictions. How do they actually make use of that? So we have a mega spreadsheet of variables that we built, and we are really trying to kind of bring it structured to this analysis. So I'm going to show you a few results that we have. So the first thing in terms of who participates in this market for forecasting. So on the demand side, you see that this practice of collecting forecasts is more widespread, or in economics, far more widespread, and for field experiments. And for field experiments, you could think that part of the reason is that field experiments are very costly to conduct. There might be a lot of downside risk involved in running these studies, and so the returns to collecting forecasts might be higher. On the supply side of forecasters, looking at forecasters, they tend to be recruited from a variety of pools, but there is a strong emphasis on academic expertise. Okay, so there are various dimensions of expertise. You can think about vertical versus horizontal expertise, the importance of understanding context, domain. Right now, a lot of papers really focus on academic experts. Use of entry, convenience samples. So here you could think of, in some context, for instance, the nature of the task. Suppose it's a study on entry itself. Then it could be useful that the enters also have an understanding of the context by this forecast. There's also a large heterogeneity in the sample size that is being collected. How many forecasters are asked to provide their feedback? And that partly reflects the fact that studies have very different goals. So if one of the goals of your study is to assess heterogeneity in performance, of course, you need to have a fairly large sample of forecasters. If you want, when you want to try to understand is, try to select the best treatment arm. I'm going to talk about wisdom of crowds. Often the returns to having already a small number of forecasters are quite high. Importantly, the objectives for kind of collecting these forecasts are not always made clear in the papers. So it's not always easy to assess exactly how to interpret this evidence in light of the results. So I'd like to kind of think with you guys about potential objectives that could be important here for collecting forecasts and difficulties using this institution. So the first thing that is often mentioned is this idea of trying to assist with the evaluation of scientific claims. And here we want to try to think about how much are we learning from a study, how much knowledge is produced, and contextualizing this knowledge is very research finding within the body of knowledge is one of the reasons that people move forward. There's also this issue that people, we might really struggle to discard our own information set, and there is layers of knowledge that might be very important for assessing scientific evidence. Once we observe results, we might use our posteriors instead of using priors to assess the novelty, the importance of a result, and that could be one way of fighting against this high-type bias. Other potential reason is to fight the publication bias that our researchers are facing. Of course, well, a new result depends. An effect size of 0, well, depends on your new hypothesis. Now, if you choose a different new hypothesis and you use the list of experts, now potentially you can reject your group. And then there's this question of assessing the replicability and plausibility of results, more generally thinking about generalization. That could be important.
Just wondering if there's any discussion about using forecasting to allocate funding.
I will end with this. There are other reasons we might want to use beliefs, crowdsource forecasts. It could be for peer review. It could be trying to think about impacts of studies more generally. And that could be one big thing. Of course, there are trade-offs, right? I mean, someone who thinks for 5 minutes about a study, and what's the objective truth? There's no such objective truth. I mean, we go back to one of the questions that Max asked yesterday about taste versus quality. What is quality itself is not completely obvious.
In terms of these arguments, I guess David talked a bit about this morning, right? With this paper with Alex Frankel, which talks about how decisions should be affected by these priors. And there we talk about two very opposing forces in a way. Like one is the surprisingness is good because we learn more from surprising results, right? Whether for decision making or for social learning. So that kind of speaks towards this informs what null hypothesis we should have. But then there's also the opposite force, which is very surprising results are implausible, right? So if we think there's some underlying quality that we're unsure about, some underlying bias that we have some prior distribution over, then if something's very far out, it suggests something wrong about the study.
Absolutely.
And so you can have those two forces kind of playing together, that it's actually the intermediate results that seem the most relevant ones.
Absolutely.
But the point is just like we wrote down some formalization of arguments along these lines.
Yeah, and also the objective function is very important. So I'm gonna go back to also what movements of the distribution we're interested in and try to think about disagreement versus, these things are so important if you have concerns about robustness. So contextualization, yeah.
So I have a question here. I wonder in the context of experimentation where, often, especially in the medical context, maybe not, there is this criterion of equipoise where you're supposed to have this uncertainty. You don't know whether the treatment is going to be effective.
Yeah.
And, this is a way to elicit is that being used in the context or, just more a question, it's relevant in the context.
I mean, I've been having the discussion, just in terms of selecting studies, right? Like, I mean, in a sense, if there is more trend, we want to go and select a treatment or study where there is more uncertainty in it, yes, to do this. And I've been having a lot of discussions actually about how these things are decided when it comes to replications, for instance. So I think right now what they're doing to ensure instantive compatibility, they put positive weights on any study being potentially replicated, but they put different weights on different studies. And I don't think they've done precisely what is best. And I'm not sure if this has having been used actually for medical trials, right? Like that.
So I think another aspect that's conceptually important here is the arguments was making, I guess, that are here about like you have a single prior and you want to assess a result in light of that prior.
Yes.
But another thing that's happening here, which is a bit confusing about this, it's not just one prior, it's many people's priors potentially. So there's like a belief heterogeneity.
Exactly, absolutely. And one part of the work of this, so to be very frank with you, what I thought we were gonna do was, the way Toussaert pitched this to me was, let's do a systematic review of meta-analysis. And then I stumbled on all these things, trying to understand what do we mean by surprisingness, so I would love to have discussions about how to actually formalize this, and that depends on the decision criterion. And if you're in a subjective expectability framework versus robust maximum framework, these things, the answers are actually quite different. So trying to formalize it, I think is very important. Another reason that people mention is this idea of understanding basically the world. Okay, so one thing that we might want to understand is why people make certain choices. And we know that beliefs, expectations, I want to explain, are inputs to behavior. So that could be one reason for collecting this type of forecast. And another important tool or a reason for using forecasts might be for study and treatment selection. And here I'll show you in a second. There's ways in which this can be used. This hasn't been used very much for that reason. So we could think that, as Marco alluded to, we could potentially use this to select which studies are going to replicate, or identify treatments that could be more impactful, or try to think about where there is more stuff to learn. And depending on the objective criterion, we might have different ways of proceeding. So that brings me to this other point that I just mentioned, which is often there is no sort of explicit discussion about what statistics should we try to pull from this distribution of forecasts. And depending on the goals of the forecasting exercise, you might care about very different things. So for instance, if what you want to do is kind of find the most successful intervention, you might want to really use wisdom of crowd, aggregate forecasts, maybe put different weights on forecasters into a single goal prediction and try to really maximize your accuracy. And here on the first moment of the distribution is something you're going to care a lot about. If you're really worried about the riskiness of the intervention, you might really want to look at expert disagreement. And here again, depending on your concerns, if you have robustness concerns, if you're a maximum type of agent or US adverse type of agent, you might want to go with lowest disagreement, even condition on the mean, thinking about just preserving spreads. If you have concerns for novelty, or maybe you want to go with most disagreement. So let me show you what people say in the data in terms of why they use this forecast. Most researchers cite the desire to contextualize their results. With respect to this academic consensus, if there is one. And to do this, we just collected the rationales that were reported in papers and the result, the word result really pops up. So really a focus on contextualization. We also try to break this down in a more qualitative way, trying to provide a classification scheme that we try to corroborate with ChatGPT. And so I'm going to just show you this distribution of motives, and here with a finer breakdown. So if you look at contextualization of results, a small fraction of people explicitly mention hindsight bias or qualification bias. Trying to show whether results are surprising or informative is in a big section of this. Trying to look and think about the inherent value of beliefs is the second motive. And here is like really trying to think about either interpreting behavior through the lens of beliefs or just trying to understand what do people think more generally about robustness or what do they know about the literature. You have a few alternative motives, like friends using beliefs as input to decision making for policymakers who might not have decided yet, or trying to assess the performance of forecasting more generally. And then you have a small fraction of papers, some that use this to inform research design. So if you want to think about, for instance, statistical power, trying to understand some sense of effect sizes, or selection of treatments, another issue. Just looking at the number of papers that actually try to kind of think about quantifying the value of how much are we learning from the experiment, I didn't see that many papers actually made explicit attempts. So for this, we need to measure prior and a posterior belief in some form, at least compare this under some set of assumption. And there are two approaches I can see. And there is a structured approach, making a Bayesian assumption, and trying to really be explicit about modeling likelihood and so on. And Rachel Meager does a lot of this work. There is a very nice paper in the set that does that. And so here you could really think about this as a normative benchmark. But another thing you could just do is also elicit prior and posterior beliefs about some hypothesis before and after having seen the data. And I don't know of any paper that actually has done this, at least in our list of papers. And we discussed also, this notion of surprisiness, how to think about this. Conceptually, at the moment, I'm a bit struggling to sort of think about or tease apart this idea of surprisingness from novelty. And it goes back to what you're saying about credibility. I don't know if there's something different about it. I would love to try to have a chat about how to model this and conceptualize this.
I have a conversation about it with IO economists where if you fit your structural model and then you get a demand slope that has the wrong sign, you just change the model until you get the right sign.
Exactly, yeah.
And so it's a bit kind of this surprisingness logic that somehow something must be wrong.
Yeah.
The value of information depends not only on the beliefs, but also on the utility.
That's also right. And that's you're absolutely right? So in a sense, if we are in two different states and the utility is actually the same, why should we care about this? We're not there, right? So here, even this is not there. So of course, this is the second element that we would need to have, and we don't have it. So you're absolutely right. So another thing that we might want to kind of think about here is when forecasts are elicited. And that I find a very interesting question because, well, if I know as a forecaster that researchers have already private information about the results of their study, then they're no longer going to recover or get a prior belief from me. So that's actually quite important. And if you look at the distribution of papers that have done this, a large fraction of these papers collect forecasts after observing findings of the study. So then there's this question of how does the timing affect or predict the distribution of results that are observed in the studies. So you could think that, for instance, researchers that collect forecasts after seeing results do this potentially because they have a new result and their returns to collecting forecasts, some they might perceive, are higher because they use this as an enhancement. So we try to understand if that's actually the case. It's not completely easy to classify. Researchers are not always completely clear about when the forecasts are being collected relative to the actual data. And so the way we try to do this is to try to compare papers that are pre-registered forecasts alongside the main study versus papers that either did not register forecasts or did this later. And what you can see here, I'm going to show you the distribution of effect sizes for papers that for which there was no registration of forecasts, or they were doing the registration after results versus before. And what you can see is that there is more of a peak at zero effect observed for this type of papers. So if forecasters understand that, they have this intuition, then of course inference becomes problematic. So what we want to try to do now, and that's one thing on our to-do list, is trying to understand, is it the case that actually papers that have no results are more likely to collect forecasts relative to similar papers with similar characteristics? And how does this affect inference? Do actually researchers, forecasters that are being asked to evaluate findings understand, take this into account? So in theory, that could be a problem. In practice, I don't know. So now I want to tell you a few things about how forecasts are elicited. And here there is considerable heterogeneity, which is not great news for meta-analysis, but it's important to look at. So authors tend to elicit forecasts primarily for understanding treatment effects, even though I already mentioned to you application outcomes as being a possibility. And use of elicitation methods is highly varied. So there is heterogeneity in the choice of outcomes, and we see people eliciting probabilities, proportions. Even how to elicit effect sizes is really not obvious. You could think about levels, difference in levels, eliciting directly a difference. Cognitively might be very different and generate different types of biases. You might want to ask about the standardized effect versus non-standardized. And here there's a huge variance. In terms of procedure, you could think about simple individual surveys with no incentives. You could think about surveys with competitive incentives, accuracy incentives that depend on relative performance. You could think about having a market. All these things obviously might have important implications for accuracy, and we don't know very much. So I just want to show you a little bit of variation that we observe. Also, we see that virtually 80% of these papers actually are interested in the prediction of the treatment effects. A few papers, for instance, look at kind of benchmarking for certain behaviors. And that could be used, for instance, for observational data, if you want to try to look at prevalence rates in a given population. And not much else. In terms of sort of use of institution, so all of these papers use individual elicitation and sometimes alongside something else. So you have these 7 papers making use of prediction markets, and then you have some balance in terms of those papers that use some form of incentive versus no incentive. In terms of how this is asked, which is actually quite an important thing for a design element, because it will drive our interpretation of noise and accuracy more generally, is how predictions are entered and formulated. And you have a large fraction where it's just text entry, sometimes with no bounds for how to actually formulate those forecasts. And sometimes actually with careful choice of bounds, but of course that could actually drive the way people think about this. So I would like to tell you a little bit more now about performance, forecasting performance. This is super preliminary. We might be on this set of stairs. It's one of those things where we're not sure how much we were going to do, and now we have the raw forecast data. So we are trying to actually something that's more standardized than just analyzing papers. So it's going to be based on a subset of studies for which we collected the raw forecast data. We merged everything together, and now we can look at on performance for a given target outcome in a given target study of a given forecast. Right? So that's the type of exercise we want to try to do. And for a subset of analysis, I'm going to separate treatment effects from binary outcomes. Admittedly, they're very different classes of outcomes. And so how should we think about forecasting performance? So different criteria that could be important. And here again, the choice of criteria might might draw a very different picture depending on what criteria we use. First, in terms of accuracy, people might be very good at predicting directions. They might be very good at understanding correlations, but they might be very bad at understanding levels. Size of deviations might be quite large. And here, to understand, for instance, the size of deviations, we need to think about benchmarks. And often the performance of forecasters is quite sensitive. I mean, what conclusion we draw is quite sensitive to the choice of benchmark. So I think that's quite important to discuss this. The second thing is people could be actually quite close to the truth, but systematically over-predict or under-predict. And we want to try to understand for what classes of outcomes would this actually be the case, and is there a systematic tendency? Through this journey, I have realized how difficult it is to run a meta-analysis. And I'm scared of a few things. One thing that I'm scared about is standardizing and making completely incorrect assumptions. And another thing is aggregating things that have nothing to do with each other. So that's my current feeling about how doing meta-analysis. I find this very challenging. And I often have in mind this blog post of Uri Simonson talking about bringing together calculating means or things that are completely not comparable, and we would like to avoid this as much as possible. So trying to do a lot of disaggregated analysis whenever needed.
But I mean, whether that's a problem or not, it really depends on what you want to do with it, right? I mean, it can make perfect sense to talk about the distribution of numbers that are substantively unrelated. Right, for instance, if you care about things like estimating publication bias, that's perfectly fine in some sense.
Mm-hmm. Yeah.
Whether the mean is interesting, of course, depends whether how they're substantively related. But
yeah, it depends exactly on the claims you want to make. Yeah, you want to make a general claims about the effectiveness of something, and then I mean,
for instance, you could have different studies using different methods, where maybe some observational, some experimental. There's some trial distribution, and part of the distribution is variation that's generated by the method, but it's perfectly fine in a way.
Yeah, I mean, in a sense, it always depends on sort of the claims that you make on the basis of the evidence you have. So here I'm going to show you on just how good our people are at understanding the direction of events. And I'm going to show you this for continuous outcomes and for binary outcomes. So here I'm showing you for standardized effect sizes. And the overall correlation, I think here we just looked at rank order correlation, experiment correlation, is fairly weak. Okay, but you have a sense of direction that people understand what could be larger or smaller effects. And there is actually huge variation across studies in terms of this dimension of performance. And I would like you to show you this for differences versus levels. So actually, people are very bad, and I'll show this, well, in fact, I can show you this here. People tend to be very biased in terms of their estimates of levels, usually strong upward bias. And you can see, for instance, that at 0 in particular, they're very wrong. So it's all over the place over here. For larger effects, they do much better, and there's drastic heterogeneity. Here, the ordering, obviously, the relationship is very weak, but the ordering is a little bit better. I think the Spearman is 1.3, and here it's virtually 0.
What's the color?
Different studies and the outcomes within the studies. So for discrete outcomes, here I'm showing you the probability that was assigned to the success if the event occurred versus did not occur. And what is interesting, so it goes in the right direction. Again, you here observe median, mean, and so on. But people tend to make more type 1 errors than type 2 errors. So they more correctly predict a success than a failure. And if you look at the performance of various institutions for eliciting beliefs, here I'm gonna compare from those papers that you see both via prediction markets and surveys. You see that prediction markets tend to be a bit more discriminating than surveys. So forecasters can get point estimates very off, even if they actually get correlations right. So it's important for us to also think about prediction error and how to measure this. And here there are many choices that we could make, right? So if we think about mean square forecast error versus mean absolute error, we're going to put different weights on large deviations, for instance, in a way that we need to think about. And so today I'm just going to show you the mean squared error for the average forecast. And the way we're going to aggregate this, we're going to be thinking within a paper and within a certain class of outcomes, average the performance for these outcomes. And we're going to consider two benchmarks for assessing performance. The first one is a random, if you want, monkey benchmark. If you just ask someone to type a number that will be allowed within the domain of the forecast and putting everything as equally likely. That's our first benchmark. The second benchmark is a null model, uninformed benchmark. If you ask me to predict a treatment effect, I'll just going to tell you 0, whether the intervention, the effect will be positive or negative, depending on what we're trying to do. And for replication, I'm just going to say 50%, as if I had 0 information about the study.
But that's not what you. 50% is a pretty particular number here. It's not as neutral as like a 0 treatment. It's like particular power for a particular sample size, particular effect size.
So it's not clear to me what else I could do. I mean, in a sense, it's kind of thinking about someone who doesn't know. I mean, another benchmark would be that no study replicates, for instance. That would be another benchmark. So I want to show you here how each of these dots corresponds to a given paper for a given outcome. Okay, so we're looking at outcome class. Here I'm showing you the performance relative improvement in terms of mean squared error of the average forecast relative to the random benchmark. Here we drew 1,000 draws from the random benchmark to compare this against. And as you can see, is performance tends to be higher across virtually all studies. We don't have confidence intervals yet, but this is coming. Importantly, depending on the study, the performance can be much higher. So here, part of the reason is design. So if you allow forecasters to enter anything, of course, then the random benchmark might be much worse. Now, if you look at this relative to some uninformed benchmark, actually even for the average forecast, performance is not so great. And in fact, from the median forecaster, it does not do much better. The median paper, sorry.
Would be interesting to test these results on the variance of the study, see if there is any correlation with the design of the study.
Yes, absolutely. One thing also we want to think about is sampling error, which we think more generally is in a sense like there's a target effect, people are trying to guess about it, and then there's an estimate. One thing that we want to do is actually want to have two benchmarks. One benchmark is an omniscient benchmark, which basically assumes that people observe actually the estimate and try and take into account the sampling error. So that would provide some information about what you're asking. And the other benchmark that we want to think about is having an LLM benchmark that would account for kind of, if we want to capture the state of knowledge, right? We could instruct the LLM to take into account all the published literature up until the point where the forecaster has to make the forecast. So we are trying to investigate that. So I told you about accuracy, trying to think about correlations and size of deviations. I would like to tell you a few things about biasness. And here what you can see is that both predictions of effect sizes and replicability tend to be biased upwards. So here I'm gonna show you the difference between the forecast mean and the effect size. And I want to show you this for this different papers that actually listed effect sizes in terms directly in terms of different treatment effect. And then where they asked questions for the level in the control and the level in the treatment, and then calculating the difference like this. And the bias tends to be much larger for levels. If you look at replication probabilities, here it's again quite useful to you to look at performance from different criteria, because what you can see is that the bias for prediction markets is actually, if anything, larger than for surveys. So surveys are just more compressed in general. There is more compressed towards the center, less discerning, and could be closer to 50%. So we haven't done very much work on this, but I want to tell you a little bit what the literature has done and our prior findings on this. So up to now, we looked at the average forecast in the dataset, and we tried to compare the performance of the average forecast relative to some benchmarks. Now we would like to ask, how does wisdom of crowds, so looking at the average forecast, perform relative to the individual forecast? So we could look at the average of mean square error for the individual forecasters versus the mean square error of the mean forecast, right? And here what we can see, and we can ask, we can do the following combined statics type of exercise. We can ask how much performance improves if I look at small crowds, say of 5 forecasters versus 10 versus the anti-sample. How much does this improve?
Mean square error, that's kind of a mechanical thing, right? It's a variance across forecasts. It's kind of calculated.
This variance across forecasts, yeah.
I mean, like the mean square error is going to be the squared error of the mean forecast plus the variance of the forecasts. Slides.
Yes. So maybe for absolute error,
I mean, that's not automatic. I'm just telling you. It's just saying it's.
You should expect an improvement. Like, question is how fast is the improvement?
Yeah, and that's going to depend on just the variance of the forecasters.
Yes. That's right.
Then you can write it down in closed form, I guess. But
Yes, you're right. That would be very useful. I can skip this conversation. So here I just want to show you the average performance. Think about having an index of performance for individuals versus crowds. And here what we do is we look for all the forecasts that individual forecasters had to make. How often is it that they do better than either the random benchmark or the uninformed benchmark? And we do this, so comparing the crowds and the individuals. And as you can see on the improvements, for the uninformed benchmark, the individuals were doing actually pretty poorly relative to the uninformed benchmark, and so the improvement of the crowd is actually quite substantial. For the random benchmark, the individuals were already doing quite well, and there is only minor improvements. In particular, that's really bad performance. So what we've learned so far on performance, we see that forecasts tend to be informative, but if you look at the median forecasts tend to be an overestimate. And that's in line with the behavioral literature on overconfidence and overoptimism. So one conjecture is that authors seek forecasts for no results, but maybe they are not conditioning on the fact that, forecasters are not conditioning on that fact. Seems that wisdom of crowd estimates improve quite fast with sample size. And here I should look at the variance of forecasts among individual forecasters. What we would like to understand is also when is that wisdom of crowds does worse and why. And then other things we would like to do is trying to look at individual determinants of performance and forecasting accuracy. So can we identify super forecasters in the data and try to better understand the trade-off between quality and quantity. So for instance, is it better to go and ask 10 academics versus go and ask 100 entrepreneurs. And that might very much depend on context. So a few thoughts that I had as I looked at the papers and the use of this practice. So I think it's here an open question of whether collecting forecasts before seeing results is important. In theory, it seems it could matter, at least for the type of quantity that our researchers might be interested in recovering in the first place. We often, if you want to understand the state of knowledge, I think it's really important that there is a clear understanding and discussion of the rules for sampling forecasters, what are the reasons, the rationales for selecting for different pools. We didn't find very many studies that look at noise of predictions. It's actually quite difficult if you have to give a point prediction for a standardized treatment effect. It might be very difficult to assess. How do we think about noise in this context? How do we take into account uncertainty and certainty in the estimates in particular? We didn't see very many forecasts for observational studies. What about macro or theory? Maybe how people interpret results, thinking about whether things always look obvious after the fact, but of course, being able to articulate this would be useful. And we've found very few papers leveraging forecasts for design more generally, which seems could be useful. And then I think there are a lot of open questions in this area. I think so many papers that could be written on this. How do we organize as a community on the collection of forecasts? Providing forecasts as an academic is a public good, and we know it's underprovided. How do we systematize this? If we go and ask our friends, maybe that actually is a very biased view of what's the state of knowledge. And so how can we think about maybe combining human forecasts with in more hybrid models with machine learning? There's this question of what are the returns to forecast production. And one argument is that maybe it could help the publishability of the results. But for this, you need to have random variation to try to really understand what are the returns to adding forecasts into a paper. This question about the incentive problem of forecasters having very heterogeneous returns for collecting forecasts and how this might affect inference, as I mentioned already on the slide. How do we improve forecast accuracy? And here, I think there's this important question of what is an expert, and we might be good at understanding. We don't even know if are we good at understanding publication bias next, and so and correcting for it. And then there are this question of understanding context, and that could be very important if you want to think about an experiment in a developing country. I don't know why this is not why we shouldn't ask someone who actually lives in the relevant context. And then there was this question about using forecasts more generally for other aspects of the way we conduct research. One thing that we might want to do is try to think about assessing beliefs, more general beliefs about research practices on sensitive topics. So one of the reasons why I asked Aurélien if he wanted to join and work on the Lab Square initiative together is because he thought a lot about Bayesian truth serums and thinking about beliefs about questionable research practices. And if you want to think about failures, for instance, information disclosure of scientific attempts, might be hard to ask people directly for their own failures, but they might have beliefs about others, and that could be leveraged to understand that. Understanding of research impact, future impact of work, and maybe as a complement to traditional models of peer review. Yeah, that's it for me. I don't know where we're heading with the project, and I'd love to hear your thoughts about what you find exciting or less exciting.
Maybe a more technical comment, but like on your benchmarking exercise, I think slight reformulation could be that you, Severine, try to predict results as well as you can without those surveys or prediction markets, and then ask how much can you improve your prediction performance by taking into account that information. I think that gives you kind of a well-defined measure of what's the value of collecting that information, which avoids you to making this more, allows you to avoid this more arbitrary choices of benchmarking.
So, but in a sense, wouldn't the LLM do this? I mean, in a sense, it's like, of course,
We're using the LLM
Right,
as they're
exactly.
doing the prediction.
exactly, right? In a sense, it's like I can only process a certain amount of information, and so that would be the value of me having this benchmark without accessing this, while the LLM can do search for the entire literature.
Maybe more homogeneous setting,
Yes.
do something like an empirical based prediction, and then in addition to the empirical based prediction, add like the survey as an additional predictor and see how much you can improve things.
Yeah.
But that gives you like a well-defined measure of what's the information value,
Mhm.
or like how much additional private information do so participants have. It's not in the public domain anyway.
Yes.
There was an expert, just an anecdote, but we ran this experiment in Jordan, and like we had our implementation partners asked them beforehand what the treatment effect estimates were. They were completely off and over optimistic.
Wow.
And then we asked the participants on the ground, like the refugees, and they were exactly spot on with all their predictions.
Yeah, context I think is super important. Like to think about this.
And interest, right? Like the NGO people, they had an interest to say like this is really hard.
Yeah.